Imagine, what if you could upload memories like files on a hard drive? What if you could install a new language into your brain overnight, or feel vibrations in your fingertips that guided you like an internal GPS? Picture this. You're walking through a bustling marketplace in 2045. The crowd is noisy, kids yelling, vendors calling out. But with a single blink, your neural implant mutes it all, isolating only the calming rustle of wind and the soft laughter of your friend beside you. You didn't take a pill or use earbuds. The machine is already inside you, fused with your biology. Sounds like a sci-fi dream, right? But here's the truth. This future is no longer confined to the imagination of cyberpunk authors. It's being built right now. Biohacking, the radical merging of biology and technology, is not just an emerging trend. It's a revolution already in motion. We're not just talking about wearables that track your heart rate. We're talking about RFID implants that unlock your front door, neural interfaces that help paralyzed patients move robotic limbs, gene editing, tools that can potentially eliminate hereditary diseases, and body modifications that push human capability into uncharted territory. The term biohacking may conjure images of shadowy hackers typing code in dark rooms, but in this world, the code is DNA. And the tools are scalpels, syringes, CRISPR kits, and microchips. Biohackers come in all forms, from the fringe DIY enthusiasts conducting experiments on themselves, to biotech companies and research labs decoding the most complex programming. Language nature ever created, life itself. To understand how far we've come, think about this. Less than 100 years ago, insulin was extracted from the pancreases of pigs to treat diabetes. Now, thanks to genetic engineering, it's synthesized using bacteria altered to produce human-compatible insulin, cheaper, cleaner, and more effective. That's biohacking. In Sweden, thousands of citizens have voluntarily inserted rice-sized microchips under their skin, allowing them to pay for transportation, open doors, and even share medical information with a wave of their hand. In California, brain-computer interfaces are enabling people to control devices with nothing but their thoughts. We're not talking about speculative tech. We're talking about tools that already exist, being tested, refined, and adopted. But with every step forward, we're also walking a razor-thin edge between enhancement and ethics. If we can upgrade our vision to see infrared light, should we? If we can erase trauma from our memories, do we risk losing what makes us human? The biohacking movement doesn't just pose scientific questions. It forces us to confront moral and philosophical dilemmas at a pace evolution never anticipated. Still, the momentum is undeniable. Every day, boundaries are being broken by people who dare to ask, what if I'm not limited to what nature gave me? What if I can be more? They call themselves grinders, neural engineers, biopunks, or simply explorers. These are the early adopters, the pioneers testing the waters of a post-human future where biology is no longer destiny. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free, and it helps us grow this community together. So what's really at stake in this fusion of man and machine? Immortality? Enhanced intelligence, the obliteration of disease, or the end of natural human life as we know it? The story of biohacking isn't just about technology. It's about power, over death, over the body, over evolution itself. In the next section, we'll trace the roots of this growing movement. From the scarification rituals of ancient warriors to the precision gene splicing of modern labs, we'll uncover how humanity's obsession with self-transformation didn't begin with microchips or code, but with something far more primal. To understand where biohacking is headed, we first have to understand where it came from. And believe it or not, the desire to transcend our natural limitations didn't begin with computers or laboratories. It began with bone, blood, and ritual. Thousands of years ago, long before the word technology was even conceived, early humans were already modifying their bodies to reflect status, identity, and power. In the highlands of Papua New Guinea, tribes would pierce and stretch their earlobes, not just for beauty, but to signal maturity, spiritual transformation, or readiness for battle. Across ancient Africa, warriors adorned their skin with scars and ash, transforming their bodies into living canvases of honor and history. These weren't just cultural expressions, they were early forms of body hacking. Primitive, yes, but deeply purposeful. Even then, we were already reimagining ourselves, one cut, one ritual at a time. Fast forward to ancient Greece. Philosophers like Plato speculated about perfecting the human form, physically and mentally. The Greeks were obsessed with symmetry, intellect and harmony, creating a vision of human excellence that, in a way, still echoes in today's enhancement culture. Then came the Renaissance, where polymaths like Leonardo da Vinci sketched machines that mimicked wings and limbs, fascinated by the idea that man could fly, move and evolve beyond biology. By the 19th century, medical science began to blur the line between healing and enhancement. Prosthetic limbs evolved from basic wooden pegs to intricate mechanical structures. Surgeons like Dr. John Hunter were experimenting with transplants long before anesthesia or sterilization were common practice. His work was seen by some as genius, by others as horrifyingly unnatural, a sentiment that still lingers today around modern biohacking. But the real tipping point came in the 20th century. It was the age of silicon chips and genetic code, of splitting atoms and mapping genomes. In 1970, Paul Berg conducted the first successful gene splicing experiment. For the first time in human history, we were not just altering the body, we were rewriting its software. Then, in the 1990s, the Human Genome Project launched with a goal that once sounded absurd: to sequence all 3 billion base pairs of human DNA. And they did. By 2003, we had the complete blueprint of our species laid out in code. It was like discovering the source code of life itself, and hackers all over the world took notice, and not just the ones in lab coats. Around this time, a parallel movement began bubbling in basements and garages: biohackers. These were everyday people, students, engineers, curious tinkerers, who believed biology should be open source. They weren't content to wait for universities or government agencies to approve their ideas. They wanted to experiment now. Some started injecting themselves with DNA sequences. Others began inserting magnets under their skin to feel electromagnetic fields. A few implanted microchips to interact with the digital world directly. It was raw, messy and dangerous, but it was undeniably a movement. One of the most iconic figures in this underground world was Left Anonym, a self-described cyborg in the UK. With no formal training, they implanted RFID chips and sensory magnets into their own body, using vodka as antiseptic and ice as anesthesia. Not for shock, but for sensory augmentation. I wanted to feel something new, they said. Their story, while extreme, echoes a larger truth. Humans have always pushed against the ceiling of biology, chasing something beyond the given. The 2010s, the tools of biohacking had evolved dramatically. CRISPR, a revolutionary gene editing technology, allowed scientists and biohackers to target and modify specific genes with an accuracy that once seemed like magic. Suddenly, curing genetic blindness, eliminating muscular dystrophy, or even crafting designer embryos wasn't just possible. It was happening in real time. But what started as a fringe idea now stood at the gates of mainstream science. Major institutions like MIT and Stanford began offering synthetic biology programs. Biohacker collectives popped up in cities worldwide, providing public access to tools that once cost millions. The movement was no longer underground. It was entering the global conversation. And yet the question remained: where was this headed? Was biohacking destined to remain a tool for health and repair, or was it inching closer to full-scale human enhancement, rewriting the rules of evolution? Close your eyes and imagine thinking of a word and watching it appear on your screen without ever touching a keyboard, or speaking to a friend across the world, not with your voice, but with your thoughts. Sounds impossible. Then meet the brain-computer interface, the crown jewel of modern biohacking. In 2020, a paralyzed man named Nathan Copeland became one of the first humans to experience touch through a robotic arm, controlled directly by his brain. Electrodes implanted into his motor cortex sent signals to a mechanical limb, and when the robotic fingers touched something, sensors sent electrical impulses back to his brain. For the first time in years, Nathan felt again. This is the power of neural engineering, the ability to not just bypass damaged nerves, but to create an entirely new feedback loop between man and machine. The company behind some of the most ambitious work in this field? Elon Musk's Neuralink. Their goal isn't just to treat injuries, it's to enhance cognition, memory, and communication. Imagine learning a language in seconds, recalling every face, date, or moment you've ever experienced, or communicating with others in silence, transmitting pure thought. Neuralink's device, a coin-sized chip called the Link, is already being tested in humans. It's inserted directly into the brain's surface and connected via ultra-fine threads, thinner than a human hair. Critics call it dystopian, supporters call it evolution, but everyone agrees. It's no longer science fiction. Beyond the brain, biohacking is revolutionizing the rest of the body as well. Artificial organs are no longer made of plastic and steel. They're being 3D printed using living cells. NTU. 2019, Israeli scientists printed a miniature human heart using a patient's own tissues. While not functional yet, it proved that customized, rejection-free organ replacements are within reach. And then there's the synthetic pancreas, developed to help diabetics monitor and control blood sugar automatically, mimicking the function of a real organ without constant human input. Some biohackers are even pushing the boundaries of sensory experience. Take Neil Harbison, a colorblind artist who doesn't see colors and he hears them. Born with a chromatopsia, Neil couldn't perceive color until he had an antenna implanted into his skull. It detects the frequencies of visible light and converts them into vibrations he hears as musical notes. His entire perception of the world has changed. He can hear the red of a rose or the blue of the sky. To him, this isn't a disability. It's a new form of identity. Neil calls himself a cyborg, legally recognized as such by the UK government. But not all biohacks involve implants. Some operate at the molecular level. Enter CRISPR, a tool so powerful it's been called genetic scissors. CRISPR allows scientists to target specific DNA sequences and snip them out or replace them. In 2020, a pair of twin girls in China became the first known humans to be genetically edited as embryos. The goal, to make them resistant to HIV. The backlash was immediate. International ethics boards condemned the move, calling it premature and reckless, but the door had already been opened. CRISPR is being tested for everything from sickle cell anemia to certain forms of blindness. And biohackers, they're already experimenting with home CRISPR kits to alter their own genomes. The implications are staggering. If you can edit DNA, you can change not just your life, but the lives of every generation that follows. Want stronger muscles, faster healing, resistance to cold, radiation, or disease? All of this is possible, on paper and soon perhaps in practice. Then there are the more extreme experiments. Some grinders, DIY biohackers on the fringe, are testing the limits of augmentation. One implanted a Bluetooth transmitter in his chest, allowing him to wirelessly stream music to headphones, using his own body as the signal source. Others have embedded compass chips, LED lights, or chemical sensors under their skin, giving them real-time environmental awareness. Most of these enhancements are rudimentary, but that's how revolutions begin: crude, risky, wild, and then suddenly mainstream. Of course, with great power comes uncomfortable questions. Who gets access to these enhancements? Will they deepen the divide between the wealthy and the poor? What happens to jobs, education, or even relationships when some people are enhanced and others aren't? If we can upgrade our minds, will natural intelligence still matter? Will the human body become obsolete? The debate is fierce and growing louder. Transhumanists argue that enhancing ourselves is the next logical step in evolution. Bioconservatives warn that tampering with nature could lead to irreversible consequences. Some fear a future where people are ranked by their upgrades, where the rich become superhuman and the poor remain, well, just human. But whether we embrace or resist, one thing is certain: the age of passive biology is ending. The age of engineered evolution is beginning. Imagine this. It's the year 2075. You're lying in a sleek white chamber, surrounded by soft humming machines. Your physical body is failing, your heart barely beats, but that's not the end. A neural preservation system, already connected to your thoughts, is preparing to upload the sum total of your memories, personality, knowledge into a synthetic vessel. When your eyes close in flesh, they open again in light. This isn't science fiction anymore. It's called mind uploading, and it's one of the most ambitious endgames of biohacking. The idea? Transfer your consciousness into a digital framework, free from disease, aging, or decay. Researchers like Dr. Randall Cohen, founder of Carbon Copies, believe that with enough brain mapping precision and computing power, it will one day be possible to recreate the architecture of the human mind in silico. A backup of you with every thought, memory, and sense of self intact. It sounds outlandish, until you remember that brain-computer interfaces already allow us to decode electrical signals associated with speech, movement, and emotion. Artificial intelligence can mimic voice, personality, even writing style. And cryopreservation companies, like Alcora, storing brains in liquid nitrogen today, betting that future tech will bring minds back from the edge of time. Could we one day defy death not by extending life, but by transcending biology? But biohacking's future isn't just about escaping the body, it's about redefining it. Take the case of e-skin, flexible, stretchable materials embedded with sensors that can measure temperature, pressure, or even emotional states. Researchers envision clothing or skin itself that can interface with augmented reality, monitor health in real time, or adapt to environmental conditions. Imagine your arm turning blue when your heart rate spikes, or glowing softly in low light, not metaphorically, literally. And then there's quantum biology. Still a nascent field, it explores the possibility that quantum phenomena, like entanglement or superposition, might play roles in biological processes. Some theorists believe consciousness itself could emerge from quantum interactions within microtubules in neurons. If that proves true, then merging quantum computers with the brain might not just enhance intelligence. It could open gateways to entirely new forms of perception, synesthetic consciousness, non-linear thought, experience unbound by time. What would it feel like to think in quantum? Meanwhile, genetic biohackers are looking beyond CRISPR. Technologies like prime editing and base editing allow for even more precise rewrites of DNA, not just snipping, reprogramming. Someday soon we may not just remove disease, we might design emotion regulation, boost memory capacity, or even alter how we experience fear, love, or empathy. If emotion can be edited, what happens to identity? And what about reproduction? Artificial wombs, also known as ectogenesis, are already growing lamb fetuses in sterile bags, supported by synthetic amniotic fluid. Human trials are on the horizon. In the future, conception, gestation, and birth might all occur outside the human body, safe, optimized, and genetically curated. A new form of creation, one that raises deep questions. Who owns this life? Who controls its traits? Where does parenting end and engineering begin? Even more radical futures await in the concept of post-biological evolution. If minds can be digital, why stop at humanoid forms? Why not bodies designed for space travel, no need for oxygen or food? Why not hive minds, shared cognition, networked emotions? Could we form civilizations in virtual ecosystems where time moves at 10 to the power of 6 speed, living 1,000 years in a single day of Earth time? And then comes the oldest question of all. If we change everything about ourselves, flesh, mind, reproduction, even mortality, are we still human? Philosophers call this the ship of Theseus paradox. If you replace every plank of a ship, is it still the same ship? Now apply that to you. If every cell is modified, every thought enhanced, every limb upgraded, where does the original you end, or does it matter? Maybe being human was never about what we're made of, but what we choose to become, and that's the real heart of biohacking, not wires or genes, but choice. The choice to push forward, to ask what if, to build the next version of ourselves with intention, curiosity, and courage. So now we ask you, if you had the chance to upgrade your body, your brain, your very being, would you take it or would you hold on to the limits that make us human? Drop your thoughts in the comments. Where do you draw the line between progress and identity? Between evolution and erasure? If this episode got your mind spinning, share it with someone curious. Like the video to help it reach more future thinkers. And tell us, what should we explore next in the world of cosmic whispers? Until then, stay curious, stay conscious, and stay a little bit human.